All right, hey guys, let's look at another problem here. In the first problem that we looked at with our goodness of fit test, we were testing to see if the color distribution of the M&Ms in the bag were uniformly distributed. Well, let's look at a situation here where we don't expect uniform distribution. So here's the setup for this problem. Okay, we've got the age distribution of the general population in Canada. We have a sample of a random sample, that's important of course, of 455 residents in an Indian community of Red Lake Village in the Northwest Territories. So way up there in Canada. And the question is, does the distribution of ages in this Red Lake Village match the distribution of ages of just Canada in general? So if we look at this, age under 5, 7.2% of the Canadian population is under age 5. Well, that was 47 people in this village. 5 to 14, 13.6% of the total Canadian population. There were 75 in the village. 15 to 64, that's obviously a big one. That's 67% of the Canadian population. That's 288 in the village. 12% were 65 and older in Canada, and that's 45 in Red Lake. So, sorry about that. All right, so what are we going to do here? Well, let's make sure our conditions are met. That's a goofy looking C. All right, conditions. First off, we've got the random. Check. What was our other condition? We needed the expected frequency to be at least 5. Well, we haven't done any of the expected frequencies yet. So let's jump on that right now. This is our observed. Let's make another one right here for our expected frequency. So how are we going to do that? If we're assuming this is the true population distribution, we expect 7.2% of 455 to be 5 and under. So I'm going to grab my calculator and I'm going to find 7.2% of 455. 32.76. Okay. Notice that this village is higher than that. Is it going to be statistically significant or not? We're yet to find out. Okay, now I'm going to find 13.6% of my 455. $61.88. All right, this one's a bit lower. 67.1% of the 455. 305.305. That's interesting. I'll just write 31. And then 12.1% of the 455, 55.05. Round up to 0.6. All right. So now when we look at our conditions, all of these are greater than 5. So we have E greater than 5 met. All right. Null hypothesis, alternative hypothesis. Population distribution matches Canadian distribution, population distribution does not match Canadian distribution. This one's our claim. All right, so let's see here. Level of significance, 5%. Degrees of freedom. Okay. Remember, that's number of categories minus 1. There's only 4 categories here, so our degrees of freedom is only 3. All right, what else do we need? Well, I think we're ready to calculate our chi-squared. So, remember our formula. Where's it at? There it is. Observed frequency minus expected squared over expected, and we need to add them all together. So, I've got my calculator up here, I've already typed in the observed frequencies. Now is where I type in my expected frequencies. So I'm going to take a second here to do that. So we got 32.76. Oh, didn't go there. Good. We're going to go 61.88. 305.31. And our last one, 55.06. All right, so I've got my list set up. I'm now going to arrow over to list 3. I want list 3 to be parenthesis, observed, list 1, minus, expected, list 2, squared, divided by the expected, which is list 2, enter. Okay, now notice that one's pretty big there. Kind of saw that one coming. These are quite a bit smaller. Hey, let's see what happens when we add them together. So I'm going to go stat, calculate one variable statistic. I still want list 3 from the last problem I did. And I find the sum to be 11.791. All right, so now it's time for my distribution. Let's find, I did look on that last video. I said I couldn't remember how the book does it. I think the book uses a 0 there because it's assuming that the null hypothesis is true. That's why they use the 0. If you want to stay consistent and use the critical, I'm fine with that too. I got to get my book open here. So I'm looking up what? 3 degrees of freedom. 0.05 for my alpha, 7.815. So that sets that like this. Chi-squared 7.815. Sets my rejection region. Our chi-squared is clearly in that. We will reject the null hypothesis. There is not enough evidence to support that the distribution of ages in Red Lake matches the distribution of ages in Canada. Okay, so not enough evidence to support the claim that the distribution matches. So we would say there is enough evidence to support the claim that it does not match. Okay, the age distribution in Red Lake is different than that in general Canada. So a cool test, again, this is called goodness of fit. We are seeing how well does this distribution fit? How good does it fit? How well does it fit the distribution of the entire Canadian population. So there's another example for you. I think you can work off this. Thanks for tuning in.